beautiful day. It's great to be live. My name's John Tremblay. Welcome to this week's edition of KCS at Home, 7th grade mathematics probability. Here we go. We're going to jump right in. We're going to review 5 learning objectives for the day. First, we'll just kind of paint a broad picture of what probability is, how we talk about it. The next 4 learning objectives will correspond with one page of your KCS at Home packet. To begin, I can describe the probability of a simple event. Now, probability is the likelihood or chances that something happens. A simple event is when one thing happens. Now, let's take a common quarter. When we flip a quarter, there are 2 sides that it can land on. And so if we were going to talk about probability, we would write a capital P. And if we were interested in our quarter landing on heads, we would put that in parentheses. Now, I'd like to express probabilities as fractions. It can also be expressed as a percentage or a decimal on a scale from 0 to 1. Now, I like to start at the total number of outcomes, which is the denominator. So if we're going to flip our coin, how many sides can it land on? Well, there are 2 sides of the coin. And how many of those 2 sides have heads? There's 1 heads on the coin. So we would say the probability of your quarter landing on heads is 1/2. Let's take another example. Let's play with some toy kayaks. I have 3 of my toy kayaks. And if I said, what is the probability of selecting a blue kayak? Well, we started our total number of outcomes. There are 3 options. 2 of the 3 were blue. So the probability of selecting a blue kayak is 2 out of 3 chances. Right, moving on. Let's go on to our next example. Learning objective number 2. I can find the experimental probability of a simple event. Now, experimental probability is something that happened. Experimental experiences. It has happened of the simple event. Let's review section 1, activity 1 worksheet, number 1. Ramon plays outfield. In the last game, 15 balls were hit in his direction. He caught 12 of them. What is the experimental probability, or the chances of the experience, that he will catch the next ball hit in his direction? A, what is the number of favorable events, which is asking how many times does he catch the ball? B, what is the total number of trials, which is how many balls were hit in his direction? And C, what is the experimental probability that Ramon will catch the next ball hit in his direction? All right, now I like to begin with the denominator first. There were 15 balls hit in his direction. And of those 15, Ramon caught 12 of those balls. So when we talk about probability, the probability that Ramon will catch the next ball hit in his direction, again, to review, there were 15 total balls. And of those 15, he caught 12 of them. So the probability that Ramon will catch the next ball is 12 out of 15. Well, we always want to simplify probability. Well, we really want to simplify any fraction we work with. And 12 and 15 share a greatest common factor of 3. 12 divided by 3 is 4. And 15 divided by 3 is 5. So the experimental probability that Ramon will catch the next ball hit in his direction is 4/5. Number 2. Learning objective number 2. I can use experimental probability to make predictions. Experimental probability is an experience. It has happened, and we are going to try to use the chances of what has happened to predict what might happen in the future. It's not guaranteed, but we can use it as a tool. This corresponds with section 1, activity 2 of your accompanying worksheets, and let's look at number 1. On average, 25% of the dogs who go to ABC veterinarian need a rabies booster. If 120 dogs visit ABC veterinarian, how many will likely need a rabies booster? This question scaffolds this for you by helping set up your proportion or two equivalent ratios. And since all percents are out of 100, we'll make 100 the denominator on our left ratio. And we're talking about 25%. And we don't know how many dogs that is, which is where we get our X. And if there are 120 total dogs, we learn we're essentially trying to solve for X. Well, that would be 30 dogs. I kind of like to do this a little differently than a proportion. Essentially, what the question is asking us to do is find 25% of 120 dogs. Well, if you recall in mathematics, 25% of means times 120 dogs. And when we multiply fractions, we could say, well, that's really 0.25 times 125, or 1/4 times 120, and both of these equal 30 dogs. So we end up with 30 dogs are likely to need a rabies booster. All right, moving on. This is learning objective. The next one, we are going to find the theoretical probability of a simple event. Now, when I think of theoretical probability, I'm thinking about the probability, the chances of what I think theoretical might happen. So what are the theoretical chances? What do I think is the likelihood of something happening? This corresponds with section 1, activity 3 of your worksheets. Number 1, a model builder has 30 pieces of balsa wood in a box. That sure sounds like a total number of outcomes. 4 pieces are 15 inches long, 10 pieces are 12 inches long, and the rest are 8 inches long. What is the probability that the builder will pull out an 8-inch piece from the box without looking? Well, how many pieces are 8 inches? Well, we know we had 30 total. And of those 30, we had 10 12 inches. And we had, oops, excuse me, I skipped that we had 4 that are 15 inches. And when we add 4 plus 10, that equals 14. And if we say 30 minus 14, that gives us 16 pieces that are 8 inches long. So we have to know that first. So the probability that we select a piece that is 8 inches long, well, we start with how many total pieces, and there are 30 total pieces. And of those total pieces, we just learned that 16 are 8 inches long. And we do want to simplify that fraction. The greatest common factor between 16 and 30 is 2. 16 divided by 2 is 8. 30, divided by 2 is 15. Having a little troubles here. So the probability that we select a 8-inch piece is 8 out of 15. All right. Last one. The learning objective is I can use theoretical probability, what I think the chances are, to make predictions about future events. This is section 1, activity 4 of your accompanying worksheets. The directions tell us to find the theoretical probability for the odd number question. And then we're going to use that theoretical probability, what we think the chances of that event, simple event happening, to make a prediction about the even number question that follows it. Number 1 is Sandra flips a coin. What is the probability that the coin will land on heads? Again, will land on tails. If you remember, probability P that the coin will land on tails. There are 2 total sides to our coin. Let's start there. And only one of those sides has the tails. So the probability that it lands on 12 is 1/2. Now, if she flips the coin 20 times, how many times can Sandra expect the coin to land on tails? Well, we would say, well, 1/2 of 20. And 1/2 of 20 is like saying 1/2 times 20. And that would be 10 total. 10 times the coin will land on tails. Does that mean it's definitely going to land on tails 10 times? No, but we think it should. And if we did this 10 times, it might not. But if we did it 10,000 times, it probably would get closer to that theoretical probability. Right. And that concludes our mini lesson, our mini review on probability. Remember, probability is the chances or the likelihood that something happens. It's a beautiful day and it's great to be alive. Bye, everybody.